Hi, everyone. Wow, that's loud. Can you all still hear? What? Hey? Let me just log on to this. Come on, my dear computer. There it is. It's coming to life. Type in my top secret password. Password, yeah, 1234. Only an idiot would have that kind of a password. Hey, that's the password on my luggage. I guess I should kick off with a Sean Connery dad joke. Does Sean Connery like all herbs? No, only partially. I run out of Sean Connery dad jokes after that, so I'm quite glad the whole half hour, 40 minutes isn't going to be that. I am Simon Stewart. I'm here to talk to you about Selenium and the State of the Union and all the exciting bits and pieces. Thank you, Dave, for the introduction. Thank you to the organizers for helping make all this happen. Thank you all for coming. I have to admit, there's a terrifying number of you. I think this is the most people we've had at a Selenium conference ever. It keeps on getting bigger every year, and it's quite humbling. So yeah, thank you all very much for being here. And at the end of it, if someone can tell me what Apple have released, that'd be really good. So yes, State of the Union. What is going on? Well, the world is changing, right? I used to begin this talk ages ago by sort of asking how many people had a phone that would connect to the internet. And in the first Selenium conference, about half the room put their hand up. Now, I think it would be better to ask, like, who has a phone that can't connect to the internet? Yeah, one of you. We'll have a whip round and we'll get you like a cheap Android device. Like Android devices, like $40 now. They've just fallen through the floor. It's phenomenal. So the world is changing. We're going from this sort of world where we've all got just a desktop to everyone having a laptop to everyone having a laptop and a mobile phone and now the watches and all sorts of interesting things. And that means that it's a wonderful time to be a technologist. Like, wow, we have amazing technology available to us. Moore's law is still going strong, doubling the computational power every 18 months. I kind of think that nowadays it's becoming distributed. So that computational power may not be in your laptop and your desktop, but it might be available to you in the cloud, right? AWS, Google, Microsoft, all these companies have massive cloud resources, publicly available cloud resources that you can use and utilize. Computing power is effectively unbounded at this point for most of the use cases that we have. Programming paradigms. When I started a long, long time ago, people were still getting to grips with this newfangled Java language, which is a bit like C++, except you didn't have to worry about memory, and therefore you leaked resources like a so-and-so. I see you've all been there then. Yeah. So there was that, and basically, you know, you looked at programs that were being written by people, and these were largely imperative, wrapped up in object-oriented code, right? So there'd be like a Java main method, which was like 40,000 lines long. People have grokked object orientation. That's something that's sunk in. People are moving towards functional programming languages. If you take a look at what's sort of happening in the JVM space, that's kind of interesting. And in the rest of the world, everyone is adopting JavaScript like it's brand new and totally exciting. Which isn't bad for like a scheme variant. And the other thing that's kind of interesting is that we now take web testing for granted, right? You know, you kind of assume that someone is doing something, and you kind of know the shape of it, right? I'm trying to think of a company that doesn't do at least some form of web testing. And the web testing is almost always done with Selenium. It's a fantastic time to be a technologist. We've got all these fantastic tools available to us. We've got computational power and we've got ubiquity. It's a wonderful thing. But, you know, we remember when times were really quite different. If you go back in time to when we started the project, when Jason started the Selenium project, the web was a very, very different thing, right? Generally, project started and survival was the goal, you didn't care how slick it was, you just cared that it went. The website went up and everything continued to work. I remember myself doing launches of websites backed with like PHP and MySQL, the LAMP stack, and being in the office for like 2 or 3 days on a trot as we desperately try and hold things together. Was that me? It's the volume, is it? There we go. I'll use this one instead. Can you all hear me still? Excellent. Yeah, so websites, you throw them together, and just having the damn thing work was something of a miracle, right? I think we now kind of take that for granted. You could deploy from your GitHub repo. Most people have seen tools that do that, and deployment is now a non-issue. It's kind of fun. And that was because, getting to the market was more important than working flawlessly. People, how many of you remember like this site best viewed in Internet Explorer 4, or optimized for 1024 by 768, which at the time was an absolutely gargantuan screen resolution, and which you're now probably wearing on your wrist. Because, back in the day, apparently we had terrible eyesight. But we also had like 15-inch monitors. They were super tiny, weren't they? You'd just peer at the thing and it would go. Anyway, I'm showing my age, aren't I? Yeah, getting to market was more important than working flawlessly. And part of that was that the web was still a marvel. For those of you who don't know, that white box there is an acoustic coupler. Yeah. All right. So you're all connected to the internet right now with Wi-Fi. You would be connected to the internet. You would be connected to the internet using Wi-Fi if you could connect to the Wi-Fi. The Wi-Fi goes over the air, and it goes into the cable, and it goes to the DSL box, right? Or ADSL, the asynchronous digital subscriber line. Back in the day, we used to have modems, and modems used to have that sort of weird noise, like a sort of horror movie thing. I'm not even going to attempt to impersonate it. And before modems, and you had to go on the internet and you had to ask people to not phone anyone while you were on the net, because that would be awful, right? Before that, before we had dedicated modems, you had this device, and so you'd sort of put your handset in there, and you'd type in the number, you'd dial the number the old-fashioned way. You wouldn't even have an automated script to do it. There were no robots to do this for us, except for if you asked your mum to do it, or like a colleague or a friend or something. Yeah, I mean, that's where we came from, right? And customers were marveling at all this new technology. I remember when the first time I was working with ThoughtWorks, and we offered a client JavaScript on their website, and they're going like, no, can't possibly do that. No one will be able to run it. It's like, yeah, sure they'll be able to run it. I mean, they'll be able to crash their browser randomly for no readily apparent reason as we mistake how, where a dot or a semicolon should be. Because back in the day, JavaScript was super flaky. And even more flaky was CSS, which, you go like, I'm going to apply some styling, and then you go like, I'm now going to restart my browser. It was awful. But customers were marveling at this new technology, and they were willing to forgive imperfections, right? And that's not the case now. Nowadays, if some rogue JavaScript took out your browser, you'd be really, really grumpy. And the browser vendors have spent a huge amount of time and effort following some sort of multi-process model to try and protect yourself from the worst of the web. What did Selenium look like back then? This is a screenshot of the original Selenium RC test runner. That'll take you back. I'll tell you what Selenium looked like back then. It looked sleek and fast and capable. That's an SR-71, better known as a Blackbird. It was a fantastic plane. Sorry, slight digression. It was a fantastic plane. It could go up to about Mach 3 and climb to outrageous heights, like 80,000 feet or something. Pilots, when they were in there, would have to wear a pressure suit because they wouldn't be able to get oxygen above 45,000 feet. And the idea was that if you fired a missile at the thing, it would just fly away so fast that the missile just wouldn't ever reach it. Fantastic piece of technology, much like, here's the weak link, much like the early versions of Selenium. There we go. How was that? Was that okay? Yeah. Sorry, there's a group of committers down here. putting their heads in their hands. So going back, Jason was, who's at the back of the room there, he was working on a new time and expenses reporting app for ThoughtWorks. ThoughtWorkers are iconoclasts, which means that they never do what they're told. And they were told that they needed to use Internet Explorer to make this new time and expenses app work. And of course, they used Firefox, and some people used Opera, because they were difficult. And they'd file bugs, because not only were they difficult, they were also entitled. Like, I should be able to use any browser I want. And that was a reasonable thing, right? The promise of the web was that it was going to work anyway, right? It didn't matter what you used to view it, it was going to work. And Jason was there, and he realized that the problem was it was rife with JavaScript, this thing. And it turned out nobody really knew how to write JavaScript. So you test it on Internet Explorer and you'd break something in Firefox. You'd test it on Firefox, you'd break something in Internet Explorer. Tested on both of them, something would break in Opera. You tested it on all three of those, and some so-and-so would be running Lynx, the text-based browser, and go like, it's not working for me. You'd weep gently. And so Selenium Core, the original version of Selenium, came out of this, inspired by Ward Cunningham's work on FIT, which is a functional integration testing, which is why you've got that sort of keyword locator and action to perform model there, because it fits nicely into a table, and that's what FIT did. Except programmers don't write in HTML tables. Hold on. Are any of you programmers who write in HTML tables? That's a no, then. And so Paul Hammond and a group of other people started working on Selenium RC, the remote control to allow you to do all sorts of fun things. And that was kind of fun. In a similar vein, I was working on web apps at ThoughtWorks, and I needed to take the awful testing frameworks that we had available then and wrap them with a pleasant API. And so I developed a WebDriver initially as a wrapper for a simulated browser called HTTP Unit, and then HTML Unit. And then I was on a client site, and we had this thing about like safety of tests. So there was perceived and actual safety. And perceived safety was like, do I believe these tests are functioning? And actual safety was like, are they functioning? So one was to do with soft, mushy, weak-willed people, and the other one was good, hard facts. And it turned out that running everything in a headless browser gave you really high actual safety, really low perceived safety. And what people needed to see was a browser going click, 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 click. And so we extended it to run with Internet Explorer and Firefox. And at some point, Jason and I realized that we should merge the projects, partly because the original Selenium team were starting to get pretty tired of maintaining it, and partly because I was an idiot. And thought I'd be finished in a couple of months. And this was about 7 or 8 years ago. Selenium itself is 10 years old. Like, it's pretty ancient now. So we merged the projects and we released Selenium 2, and that was exciting. And one of the big things that came with Selenium 2 was the WebDriver API and the wire protocol. And the wire protocol is the thing that has allowed us to continue extending the project as we move forward. But times have changed, and the web has changed, right? Have we? Has the Selenium project changed enough? I don't think it has. There are several reasons for that. And if you take a look at what we're doing in the core project, it looks like we're still responding to the needs of the past. We're still trying to figure out, like, how do you click on a link? And how do you even find a link so you can click on it? Customers come to us, they download Selenium, they're starting to use it in their testing, and they expect technical perfection. And we show up and we're less than perfect, right? There are still problems, there are still challenges that we need to address. CSS transforms have caused all manner of headaches. I've seen David Burns literally tearing his hair out, figuratively, as he works in it. And so in a sort of fast-moving, evolving web, we look set in our ways, right? Like, where's this project going? What's it doing? Yeah, am I exaggerating? Yeah, I mean, maybe. Or probably maybe. Because I think we're not doing too badly, right? I think as a project, there are lots of things that we do which I'm very proud of and that I think is awesome, and I think there are things where we could do better. So let's take a step back, right? What are the needs that make us relevant today, right? What are the problems that we're trying to solve with a browser automation framework, right? And a browser automation framework that attempts to emulate how the users actually interact with their devices. And to answer that, what we need to do is we need to think about what is the modern web, right? Let's imagine that we were going to start the Selenium project in whatever year this is now, 2015. I was going to say 2010, because clearly I'm just stuck in the past. 2015, what is the modern web these days? And in order to answer that, we need to think about how we actually consume the modern web, right? You know, no longer are we trapped in what we used to do. Some of you recognize that. I'm sorry, there are folks from Microsoft. Avert your eyes now. We used to use a desktop, and lots of us still do. Like day to day, all of us are probably in a job that puts us sitting at a desk with a desktop computer or a laptop computer with many, many cores available to us, more RAM than we know what to do with, other than open lots and lots of tabs in our browser and try and figure out like why our computer is now really slow as it hits swap, which is now no longer running on just a plain disk, it's on an encrypted disk. Right? What we do is we make our computers faster and we find ways of making them run slower. This is the nature. So, I mean, like constant speed of applications has remained about the same. And what's happened is we've made computers go faster and the apps get bigger and heavier and weightier. So yes, we still use desktop browsers. They're still a key part of what we do. But we also use mobile devices. This is what phones used to look like, kids. This is actually, I had one of these. It's a Sony Ericsson T28. They were lovely, right? Like the battery would last for about a week. And like one of the super nice features is when the battery ran down, it would turn off the displays. It wouldn't work, but the alarm clock would still work. How many of you have almost missed work because your phone ran out of charge overnight and you're using that as the thing to wake you up? Yeah, a few of us. So yeah, we're consuming the internet, the web, the modern web on mobile devices as well. Perhaps not using a WAP-based interface, which never really took off the way it should have. Or maybe it did. But, you know, we've got our phones with Safari or Chrome, with sophisticated JavaScript engines that do just-in-time compilation. Some of us are viewing the web in web views, which may or may not have JIT's compilation of JavaScript. But generally, we're talking about memory-constrained devices with few cores, far fewer than we have in our desktops. And they are the primary device that people use for accessing the internet these days. And looming, we have the Internet of Things. Like, I have no idea what that means. It's a term that gets bandied around a lot, like microservices. Everyone's got their own definition. I think it's going to be like hackable light bulbs. Like you're going to have to, you know, log onto a website to turn your light bulb on. And in fact, that happened recently. There was an outage with Nest, and people had to change their thermostat using their hands. It's barbaric. It was like going back to like 2000. Horrible thing. The Internet of Things is happening, right? You know, we're putting web accessibility into all kinds of devices. So, you know, that's how we're consuming the modern web, right? The modern web is trying to be run on all of these things. And the interesting thing is, from desktop through mobile down to the Internet of Things, each step has got less and less computing power. But Moore's law means that each step has more and more computing power. Have all of you seen the demo of Doom running on someone's wristwatch? Yeah. It's like, what the heck? Like when I was a kid, like, I know, like, wow, officially mind blown. When I was a kid, like, I'd be lucky if my watch went beep, beep, and it could chime on the hour. So, you know, this is the modern web. This is how things are being used. This is what we're doing now. How do we build the modern web? Like, how do we build technologies and applications for the modern web? You know, we could do it the traditional way, traditional Web 2.0 apps, because, you know, Web 2.0 is now such a dated term that you can put the word traditional before it and it's not too ironic, which is fairly scary. And they're rife. They're lousy with JavaScript, right? The original web applications we used to have, you clicked on a link right? And there was nothing else you could click on other than maybe a button, right? And it would do a complete page refresh, right? It would go back to the server, it would go like, hang on a second, grab down the content very slowly over the crappy modem that you had that sounded like it was singing quietly or very loudly. And then it would re-render the page. And we moved from there to single-page applications, things like GWT, the Google Web Toolkit, Gmail, Maps. They led the way. But now that's basically how you write a web application. You sort of render the basic content, and then you just use JavaScript to fill in the blanks, right? And that's kind of exciting because as a JavaScript software engineer, you get to play with NPM, which is a package manager, which you use to download Bower, which is a package manager, which you use to download Gulp, which is a build tool, which you then use Webpack, which is a build tool, and then use Babel, which is another kind of build tool. And frankly, I don't know how JavaScript developers do it. Like, I spend a lot of my time writing Java, and it's bad enough having to invoke a compiler. I don't know how you do all that stuff without going totally crazy. But I'm told JavaScript is the new hotness. And our applications, our web apps, are becoming increasingly dependent on JavaScript. And that's been made possible by the fact that Chrome, Internet Explorer have spent a huge amount of effort, Firefox as well, a huge amount of effort making their JavaScript runtimes incredibly fast, unbelievably fast. Right, almost native speed fast. If you've seen the demonstrations of ASM.js from Firefox, from Mozilla, I mean, they're playing 3D games. They're rendering it all in JavaScript. It's phenomenal. But there's also, like, apps as web clients, right? We always think these two things are in competition and it's one or the other. But actually, the back end doesn't care. All it's getting is an HTTP request, maybe an HTTP2 request. And it spools out content. You can do MIME-type data sniffing. So one way to look at sort of the world of apps and websites isn't that they're in fierce competition, is that there's a continuum. Like, you can do some really nice things with modern apps, native apps on a mobile device that are slick and nice. Scrolling springs to mind, loading content, having stuff when you're partially connected. I guess Sean Connery would say partially connected. You can do all these things. You can have the content available to you. But you can pull the data from the web. And so you can marry the two things together. And you see that, in fact, with most applications. I guess some of you are on Facebook. Some of you use Twitter. Some of you use, some like the nice Gmail applications that there are. Like, they're all doing that. They're all pulling content down. They're storing it locally. They're displaying it locally. And then when they need more, they go off to the web and they grab it. Right? So the two aren't necessarily in competition. Who am I kidding? Of course they're in competition. Right? I mean, I'm not going to download a web app for every single website I want to download a native application for every single website I want to visit. Like, how many of you, when presented with the interstitial on, like, some of the sites, they go, like, download our app, it's awesome. Just close the tab. Don't even bother reading the content. It's a massive, a surprising number of people are incredibly patient, because I can't stand that stuff. For those of you at home, about a third of the audience put their hands up. So the web is attempting to compete with applications, right? So there's evolving document models. The DOM that we had back in the day isn't good enough now. You've got the shadow DOM. You've got web components. You've got the ability to sort of glue these reusable pieces together into a sophisticated UI. And that's led to a confounding profusion of CSS specifications. It's much like the DVD translations available for Downfall. No. You know the video where, like, Hitler's in his room and he's going like, what are you doing? And no, that joke just didn't work, did it? Note to self, Downfall, never use that joke again. But there are loads and loads of CSS specifications, and they keep on changing and they keep on coming up with new ones. If you just take a look at the output of the W3C, it's phenomenal. Get user media allows your website to access local devices like cameras. Geolocation allows it to figure out where you are. These are all things that are provided by the native apps, the mobile apps, right now. And so the web is finding ways to compete. And Web Workers allows you to do stuff off the main thread, quietly in the background. And so now you can do some background processing and work, which means that your application can be smoother, more responsive, and more pleasant. The web is fighting back against native apps, and it's trying to figure out how to do it. And it's right at the beginning now, I think. but it's going to get there. So how does the Selenium project stay relevant? Like, we've seen how everything is changing. We've seen how people are consuming things differently. We've seen how people are building things differently. How do we stay relevant? And how do we do that? By addressing our two core strengths. Yeah. Yeah, there are 10 kinds of people in the world. So our two core strengths. The first one is ubiquity. Like I said right at the beginning of this talk, if you go somewhere that's doing automated web testing and increasingly automated testing of native apps, they're using a variant of the WebDriver protocol and APIs, right? Everywhere you go, this is being done. And the other core strength of the Selenium project, and this is a slightly wordy slide, is a simple extensible API that provides a mechanism to interact with the tree of UI components. So back in the day, this was the DOM, the Document Object Model, which was effectively a tree of nested trees, and it was all very exciting. And the Locators API, either in the original Selenium RC, which allowed a wealth of options, or in WebDriver, allowed you to identify a single node on that tree. And then there were additional commands that once you've identified that node, you can interact with it. Now, it turns out that native applications are very much the same, right? They are a tree of nested UI components, and what we need is a mechanism to find one of these things. And once we found it, we need to be able to beat the living heck out of it. If the rumor mill is true, we're going to need to be able to do like haptic feedback and force touches on iOS, which is going to be interesting because I don't think we ever thought that people might need to apply pressure when they're tapping. So precognition often goes awry, right? Looking into the future doesn't always work the way you want it to. If you've seen the film Minority Report, you know this. So it doesn't always work. It's quite often a bad idea, but we're going to do it anyway because it's actually quite good fun, right? Now I'm going to make an incredibly controversial bet, and I don't know how many people in this room are going to agree with me. Here it is. Apps aren't going to go away. Native applications on your mobile phone aren't going to go away. And there's a number of reasons for that. The first is convenience, right? I don't know about you, but I quite like when I'm in a queue somewhere and I'm just waiting, like pulling open my phone, taking a look at some of the cached messages from Twitter, even when, I'm on roaming right now, so I'm on 3G, and so downloading any content takes approximately until the heat death of the universe. But because I've got content that's cached and available to us, I can have a read, right? It's incredibly convenient. And people love their phones. Like, I'm pretty sure that if your house was on fire, you would go and grab your phone because it's got your photos on, it's got your contacts on, and you can call the emergency services on it. Yeah. And we love our phones, right? They're not going to go away, and the best way to interact with data streamed off the web is with a native application at the moment, right? And you can see this, right? These two trends lead up to things like the mobile hours spent on sites such as Facebook, but also globally around the world, are increasing to be greater than the number of desktop hours, right? The amount of time people spend on their phones and their tablets is greater than the amount of time they spend on their desktops. Just think about how you use the internet. You're probably in that group of people that are using your phones to access a wider range of content than you are with your desktops. It's kind of interesting, right? So apps aren't going away. And that means that the Selenium project must be able to test web apps, mobile apps and web apps. There's a sort of interesting thing happening. Like I said earlier, the web is attempting to become more native, right? It's putting in all these features to try and become more native. But it turns out that writing a native application is an incredibly challenging task, incredibly difficult. And it would be nice if we could take some of the skills that we have as JavaScript developers, as web developers, and apply them to native development. And you see that with projects such as React Native. I'm using that as an example. Obviously, I have to. I work at Facebook. But native applications are starting to pull in lessons that we've learned on the web, right? Ubiquity of tooling, ubiquity of languages, right? More and more of the application being written in languages such as Lua or JavaScript, a shared core that can be reused on both Android and iOS and, I guess, WinPhone. And in order to communicate with these things, we're extending the JSON wire protocol, the protocol that we use to talk to the remote WebDriver server. And that started off as an experiment by me to well, how do I control Firefox if it's running on my device but it's not in the same process? And the original version was a telnet client server that I wrote that ran inside Firefox, and you'd telnet into Firefox, and you'd do you'd say how many lines were coming up, you'd type the command, and then you'd type anything else it needed. And when it counted n number of new lines, it would then go, right, I've got all my content, and away it would go. And the wire protocol evolved from that, quite frankly, horrific beginning that demoed really well into sort of JSON over HTTP, right? It's lowest common denominator. So the JSON wire protocol is being extended to allow us to test on mobile, right? Jonathan Lips is giving a talk later on in the conference about the mobile JSON wire protocol and how we're extending it. That's going to be kind of interesting, I think. And this mobile protocol is already in use by projects such as Selenium, Appium, iOS driver. They're present on Android, they're present on iOS. But iOS is still somewhat problematic. I think anyone who's tried to write a testing framework for iOS will probably sympathize with why do I waste all my precious time. Time is sort of the thing that you can never get back, right? And trying to get iOS automated is a pain in the backside. Like, why is that? The main reason is that, and this goes back to a conversation that Jason and I had the first Selenium conference, maybe even before that. 2007, I think, was when we started having this conversation, which is the next form of testing is going to be through the APIs provided for accessibility for disabled users to interact with their devices, right? You can think of your automated test as being deaf, dumb, and blind, right? They can't see, they can't feel, they can't read. You need to do all of these things for it. But software, operating systems have APIs provided to support users who suffer from those conditions. And going through that for testing makes a heck of a lot of sense, right? Now, this is provided by a library called something like UI Automation on iOS. And that was designed for basic interaction, right? It wasn't ever really designed for doing mobile testing. And so what happens is every time Apple releases a new version of iOS, the UI automation breaks in new and interesting ways, novel ways. And worse, it's got a 1 second sleep in there between each interaction that you do, which is, incredibly painful and makes it incredibly slow, unless you hack around it, right? And then when you hack around it, the apps aren't ready, and it's a nightmare, right? UI automation allowed us to get up and running, but in order to get there, we had to build so much scaffolding. Right? You take a look at how even Appium works. iOS driver is one I'm more familiar with. They talk from your desktop to a local server. The local server converts the command into a chunk of JavaScript. That chunk of JavaScript gets shunted onto the device. The device then executes that chunk of JavaScript, which may or may not do what you expect it to. It comes back after some indeterminate period of time. The thing running on your desktop computer, running the simulator of the device, goes like, hang on a second, unpacks it, repacks it, sends it back across it. What a pain in the backside. I'm doing the G-friendly version of this talk. Later on, I'll do the R-rated version in the bar, don't worry. And to address this I don't know whether this is the final way that we're going to do it, but at Facebook we have a piece of technology called WebDriver Agent. It's a WebDriver server for iOS. It actually runs in the simulator on the device, and it allows you to run across apps. So if you do go through like the sharing dialog and you pop open like multiple screens, multiple applications, that works. It's written entirely in Objective-C and runs alongside the app on the simulator, like I said. So a lot of the frameworks we have right now attempt to sort of translate to JavaScript to interact with an app written in Objective-C, or maybe 3 of you have written something in Swift. By doing this, by running on the device and being written in Objective-C, we can get rid of loads of the middle layers. It doesn't go through UI automation. It uses the native commands available in the OS. And it supports iOS 7 to 9. Like every time Apple release a new major version of iOS, the iOS driver team and I assume the Appium team scramble to try and figure out like how to make it work. It's a real challenge, right? So being able to run on the latest version is really useful. It will be open sourced. It probably will be available at that URL. We're still working out the sort of final bits and pieces. It might not end up being called that, but it will be similar. And I will be sure to tweet about it. Coupled with that, we have FB Simulator Control. It's an iOS simulator management tool. And so that's how you increase utilization, right? You've got your Macs. Macs are incredibly expensive devices. If you can only run one test at a time on it, you're making poor utilization of the available capital that you've spent on your testing infrastructure. You might be able to spin up virtual machines, but it would be better and nicer and neater if you just ran multiple simulators at the same time. And that's what FB Simulator Control offers you. It handles cleaning up the simulator, installing apps, changing locale, blah, blah, blah. And coupled with WebDriver Agent, you can do things like, what happens if I force quit my application and try reopening it? Like, does it do the correct thing? Does it do reporting? Nothing says it's not vaporware than seeing running tests. This is a video of some tests being run with FB Simulator Control and the WebDriver Agent. You can see 3 of them being run simultaneously. You can see it interacting with native controls and doing fancy bits and pieces. If you don't know this is the Facebook application, I suggest downloading it and clicking on some ads. There we go. I won't show you all of it, but there we go. It works. It's there. And Mehdi, who is one of the primary authors of this, is somewhere in this room. I can't see him, the lights are bright. But he's a lovely chap and will probably, he's over there. There he is. He can probably tell you far more about it, far more coherently than I would ever be able to. But you know what I'm secretly hoping is happening today? I think Apple have gathered the world's press together in one place, not to announce a new version of Apple TV, not to announce a new version of their telephone. I mean, how many times do you need a new telephone, right? I really, really hope that what they're announcing right now is some sort of automated framework for app testing on it. No? I don't think that's going to happen, do you? But it would be lovely if they did that, right? So Apple, if you're listening, if you're watching this, can we have that, please? Can we have a mechanism for doing automated testing of iOS apps baked into the platform that isn't UI automation and which scales and works with Swift? That would be really nice. So one of the other problems that we have is that end-to-end testing is unstable. How many of you are happy with the stability of your end-to-end tests? Don't all rush to put your hands up. Yeah, almost no one is happy with how stable those things are. And so we're trying to figure out, like, how do we improve that, right? The state of the art, maybe with the Selenium project, isn't necessarily going and writing better APIs for tooling. Maybe one of the things we could do is start sharing the knowledge that we all have about how we've made our end-to-end tests more stable. Every year at this conference, there are at least 2 or 3 talks about how people are approaching this problem. There was a talk from Salesforce about how they dealt with flapping tests. Google have spoken before about how they deal with flakiness in their tests. Every year there's a talk about page objects and how you could apply decent object-oriented programming to try and reduce the amount of duplication in your tests. We should be sharing this knowledge and this experience with each other, right? And maybe one of the things we could do is use the project as a mechanism for highlighting some of the better approaches. And things that I've seen have included simulated backends, right? End-to-end tests are unstable because you need the entire system up and running. But there's been research done by various people into, like, well, maybe all we need is, like, we don't need the whole of the backend. We could record responses. We could have a fake server. We could have something. And there are challenges around setting up test data, right? I don't know. That can be a really complex thing. Later on in this conference, Remy is going to be covering how Facebook tackle some of these things. Stable, useful, easy, pick 3. Because normally you have to pick 2, right? Or even 1, or none, depending. I've been on projects where none of them have been picked. Like, maybe this is like one of the first steps in, like, helping to share some of the knowledge that people have experienced and gathered over all their time with end-to-end testing. It's 10 years. We should have nailed this. Right? Unstable end-to-end tests should be a thing of the past, right? It's not. It's something we all of us struggle with day in, day out. Like, how do we make it so that when a test passes, it means something? And end-to-end testing is slow. This is a picture of a baby sloth. They are utterly adorable. I didn't realize that sloths can swim. Like, I never even, like, they spend so long moving so quickly, they have algae growing on them, right? They're covered in, like, moss. That's why they're green in the wild. But they can swim. Turns out, like, there are only, like, 2 animals on the planet that can't swim at birth. Humans are one of them. I can't remember what the other one is, but it's not a sloth. End-to-end testing is slow. Like, how do we approach the challenge of making our end-to-end tests go faster, right? I mean, the obvious thing that we do is parallelization, right? And this was mentioned all the way back in the beginning when we had Selenium RC, and we have Selenium Grid now, and all sorts of fun things like that. And then we can use sort of Selenium as a service. Those service providers, such as Source Labs and Browser Stack. There are others. These are the sort of the big 2 that I have run into most of the time, right? They allow us to not have to own our own infrastructure for scaling out tests, which enables us to parallelize more easily and more broadly, right? Maybe this is one of the things. It would be nice to have some in-house capability as well. I know some people find the idea of taking their super secret app that they're going to release to everyone and testing it with a public service a bit weird. And they like to have like the privacy and the complete control. But this is certainly one way of going about it. And if public service isn't what you want, then setting up Grid with some virtual machines is the way forward. I don't think headless testing is the way forward. Like it used to be. Go back to when we started this project, applications were a lot simpler. They were basically filling in forms, right, and chucking bits and pieces in. But nowadays, with the amount of JavaScript and the sort of the edge cases that come up with that, you want to be testing in the browsers that your users are using. And none of your users are using a headless browser. Yeah, all of your apps are. Well, yes, but your apps aren't headless, right? They are the head themselves. Curl might help, HTTP-based testing. So yes, and things like containerization, Docker, virtual machines, are becoming a lightweight way of running more and more actual real browsers on an actual machine without having actual interactions. It's going to be quite good. The other thing that we need to do is we need to start looking at moving beyond testing, right? How many people here are at Selenium conference because you use Selenium for your day-to-day testing? That's, yeah, basically all of you. How many of you are here because your primary use case for Selenium is monitoring your site and making sure it still works? More people than I thought. I'm impressed. How many of you are here because you're using Selenium for doing web crawling? Like, yeah, maybe a couple of people. It makes sense, right? You've got a browser. You want to be able to go and like download content. You want to take the content you crawl should be the content that people see. So the way you do that, use an actual browser to tell you what people see, right? And automating painful workflows. In London, I know of at least one person who got tickets to see their favorite band by automating the website that you used to buy these tickets because it was so awful. And he just ran that script in parallel, I think using Source Labs, until he got the tickets that he wanted. Like that's a nice inventive thing, right? But so many of us are chained with legacy web apps. Like, could we somehow start making them go away by wrapping the painful workflows using something like Selenium? And then we need to look beyond open source, right? We started this project, like Jason started it, and one of the reasons why I was able to sort of step in and do the Selenium 2 release is because the team were tired, right? They'd been working on this thing for years. They'd pushed it forward a hell of a long way. And it was a really impressive piece of technology, but it was becoming apparent there was going to need to be a major rewrite that needed to be done. And the team had done a really good job building Selenium, making web testing a thing that you could do that was stable, but they were tired. When we started WebDriver, Paul Hammond told me I was crazy, but in less pleasant terms. Because WebDriver works by binding tightly to each of the browsers, which means every time there's a new browser release, we need to figure out how to integrate tightly with that browser. That's a huge investment of effort, right? And it's an incredibly difficult thing to do. And it turns out that the modern web is also a more secure web. All the gaps that we used to step in and automate browsers, they're being closed because they are actually security holes. And that means that the browser vendors are the people who are going to be responsible for doing the WebDriver implementations, right? And when I say WebDriver, I don't mean I mean the W3C WebDriver specification. So there's a couple of things that are going on. First of all, actually the W3C spec, which we've been working on for years. 2 years, feels longer than that. Jim tells me it's 2 years. And it could be longer. That WebDriver specification is hurtling towards becoming a recommendation. We think that'll happen before the end of the year. That will mark like a line in the sand, right? At that point, you can assume that browsers are going to support a basic set of APIs for doing automated testing, right? Which means that you can plug things into the grid. It's going to be awesome. Yeah, you can clap that if you want. And being able to slot in new browsers as they become available is super important, right? Source Labs recently offered Edge support, Microsoft's new browser, Edge, mainly because it follows the WebDriver protocol. And so some of the work, the hard work of like, well, how do I spin this up? How do I put it in? It's just another browser. It's got the same sort of model that everything else has. That's fantastic work by the Edge team, right? And shows a real commitment to open standards and the users. Firefox, Mozilla are working on making Firefox more secure, more stable. Marionette is their implementation of the WebDriver protocol. It can't come soon enough. Mozilla, Firefox is going to require plugins to be signed relatively soon, and they're moving to a model called electrolysis, a multi-process model. Both of those things have the potential to cause an awful lot of trouble for the existing Firefox driver, but if you're part of the browser, if you're baked into it, it's not a problem at all. So Marionette can't come soon enough. So those are the sort of exciting things that are looming on the horizon. Taking a step back, like what's the goal? Why are we doing all this? James Whittaker interviewed me for a book he was writing called How Google Tests Software. And his question was, so what's your wish for the future? How will browser automation tools work in the future? And I replied that my hope is they disappear into the background. Automation APIs are an expectation for every browser, and that people stop worrying about the infrastructure they want to use. People should be thinking about the new features in the web apps, not how to automate them. Selenium WebDriver will be successful when people forget it's even there. Like it just becomes part of the fabric of the stuff that we're using. Will we get there? Maybe. Maybe we're almost there. One more thing. I've wanted to say that for so long. Selenium 3? We'll get there one day. Ladies and gentlemen, thank you for your time. I hope you have a great conference.